Hey guys, so today I'm going to be going over how to write absolute values as piecewises. And so with that, let's get started. So let's say that you had the function f of x equals the absolute value of x, right? If you were to graph this, you would get a function that looks like this. Oops, sorry. Kind of an inverted V, right? And so that's what your function would look like. And the reason for that is because if you had x and then f of x values, right? And then you had -1, or I'll start at -2, -2, -1, 0, 1, 2. Then this would be the absolute value of -2, the absolute value of -1, the absolute value of 0, the absolute value of 1, and the absolute value of 2. And this would give you 2, 1, 0, 1, 2. And if you plotted these, that's what you would get here, except this would be more symmetric than I've drawn it, of course. And so when considering this, if we wanted to be able to write this function as a piecewise, which is just writing a function for values of x, how would we do that? And so what we do when we want to do something like that is we write f of x is equal to, and then curly brackets, and then we're going to have some type of statement that explains what domain or what range this function is on. And so in this example, we're going to say when x is greater than 0 and when x is less than 0, because that's when the graph changes its behavior, right? Because from this point to this point, it's just a straight line. And from this point to this point, it's just a straight line. And the other thing to note with these piecewises is that we don't use absolute values in the actual piecewise. And so what I mean by that is that we don't write absolute value of x and absolute value of x here, because otherwise we would just write this. But we're trying to break down our function a bit more into some smaller components here. So we don't use our absolute values when writing our piecewises inside the actual piecewise, that is. And so if we want to write this a different way, how would we do that? And well, when x is greater than 0, it's just going to behave as if you graphed x, right? And so what I could even, I'll color code this for you, we could even just write it as x, because if we just graph x when x is greater than 0, it's just going to look like that, which overlaps nicely with our absolute value sign. But if we wanted to write x here, let's say, we couldn't, because if we were to graph x when x is less than 0, it would be going down into the negatives, right? So how about we fix that by taking the negative of x? And so the negative of x is going to look like that, and that matches nicely with our piecewise as well. And so that's what we can do in most cases with absolute values, is use this negative when x is less than 0, when x is actually negative, is what this x is less than 0. X is negative. That's what we'll graph, right? And so this makes sense as a way to write it. And so I'll do a few more examples here. And that was a general explanation. So now I'll skip some steps when I'm explaining, just so that we can get through these examples concisely. Okay, so let's say you have the function f of x is equal to the absolute value of x minus 3, and you're asked to write a piecewise for it. Well, what we usually do is say, okay, x minus 3 is equal to 0 where? And x minus 3, if we just solve for this, x is equal to 3. And so we can write this then as f of x is equal to curly brackets x minus 3 if, forgot my comma there, if x minus 3 is greater than 0, and negative x minus 3 if x minus 3 is less than 0. And we usually include an equal sign on one of these. We could include it here, or we could include it here. It really doesn't matter, but I've included it here. And so thinking about this statement, we're saying the absolute value of x minus 3 is equal to x minus 3 if x minus 3 is greater than 0. So this is just saying if x minus 3 evaluates to positive, and this is saying if x minus 3 evals to a negative, then this is what we're going to have to use, these two statements right here, okay? And so that's what that is saying. Let's do another example. And this can be confusing because there's a lot of terminology going on here. So I would just encourage you, work out these problems on your own and talk yourself through it, and that should help. Okay, so now let's say that we have f of x is equal to the absolute value of negative 3 plus x over 5, and then absolute value sign, right? And then we're asked to write a piecewise for it. Well, what you could do in this case is same thing as the last one, negative 3 plus x over 5 equals 0 when, and then solving for x, negative 3 plus x is equal to 0, because if we just multiply 0 by 5, like that, or like this, right, these are going to cancel, and then this is going to give us 0. And so that's how we got there. And then adding 3 and adding 3, that's going to give us x is equal to 3. So that's the point we want to write our piecewise about. And so we can write our piecewise then as f of x. I'll change colors here actually, just for some fun. F of x is equal to, I'll make my bracket a bit nicer. F of x is equal to negative 3 plus x over 5 if x is greater than 3. Or we could also write this part here, this x is greater than 3 part. You could also write that as x minus 3 is greater than 0, right? Just moving it around like we did in the last example. But usually we like to just have our x's as alone as possible, which is too bad for the x's, I guess. And then we, just like the first example and the second example, we could write a negative out there. If x is less than 3. And keep in mind, what this is saying is the absolute value of negative 3 plus x over 5 is equal to negative 3 plus x over 5 if x is greater than 3, and also equal to negative of negative 3 plus 5 plus x over 5 if x is less than 3. And so just walk yourself through those steps, and hopefully over time you'll be able to get it. And that's okay if you don't get it right away. I didn't get it right away either when I was first learning this stuff. Just it takes some practice. Okay. And so our next example is going to be dealing with the color green, and the question, f of x is equal to negative absolute value x plus 4 absolute value plus 5, right? And so now you may say, well, what do I set equal to 0? And in all the other examples, what did we set equal to 0? The term inside that absolute value sign, right? This guy. And so we're going to do the same thing here. So what we're going to write is x plus 4 is equal to 0. X is equal to negative 4. And so then we can write this as f of x equals to squiggly bracket x plus 4 plus 5 if x is less than negative 4, because now that this is a negative number, right? If we subbed in a number less than negative 4 into this equation over here, it would be positive. So if you don't believe me, work it out for yourself, but that's how it works. And then here, negative x plus 4 plus 5 if x is greater than negative 4, right? And then we usually have our equal to sign in one of these, so let's write that. Okay, so this is probably the toughest example. Let's say you have f of x equal to the absolute value of x minus 5 plus the absolute value of x plus 3. So what are we going to do here? The same thing as we've done in our previous questions, right? X minus 5 equal to 0. X is equal to 5. And then for this other guy, x plus 3 is equal to 0, meaning x is equal to 3. Negative 3, sorry. See, it's easy to make mistakes in these problems. And now we're going to want to write a piecewise for that. So if we write f of x is equal to squiggly bracket, and then let's write our terms first for this one. So we're going to say if x is less than 3 is going to be one term. If negative 3. If x is less than negative 3, if negative 3 is less than or equal to x, which is less than or equal to 5. And last one, if x is greater than 5. And so how did I come up with these bounds? You'll see here that, for example, with this guy, when x is less than negative 3, I'll just write out a number line actually for you guys. So what this function is going to look like is we have negative 3. Let me turn off my straight line here. We're going to have negative 3 and 5, right? And so one thing's going to be happening over here. Then let's say another thing is going to be happening here. And then finally, something else could be happening over here, right? And so we need to account for all of those. And so that's how I got my my parameters here, is when x is less than 3 is this way. When x is less than or equal to negative 3 or less than or equal to 5 is this guy in here. And then when x is greater than 5 is this guy over here. And so hopefully that made sense to you, the way that I explained it. And so that's how I got my parameters. And then I'm going to write out some statements here for you guys now. And so what we're going to say is that negative of x plus 5 plus the negative of x minus 3. And so why did I know to write that? It's because we're saying when x is less than negative 3, actually, I'll just pull up my number line again. I'll write it again, right? We had -3, and 5. And so over here, both of these functions are going to be negative. So that's how I knew to write them as negatives, because if they're both going to be negative because they're both absolute values, we can't have them being negative, so we have to make them positive. So here I'll write both negative. And then here, just because I'm thinking about it right now, one of them, 1, negative, well, actually, sorry, no. Here, both are going to be positive. And here, 1, negative, 1, positive, right? Okay, and then I'm going to go back to writing my equations here. So then for this one, 1 negative, 1 positive, the one that is negative is going to be x minus 5, so we're going to need to put a negative just in front of that guy. So x, oh, sorry, I actually didn't realize I wrote a positive there. That should be negative, my bad. Negative, so x minus 5, and then plus x plus 3. And then this guy, because they're both positive, I don't need any, I'm writing positive again, I don't need any negatives in front, so I can just write this. Oh, and this guy, I screwed up. Anyways, this is the correct version of the piecewise, and so now I'm just going to go ahead and simplify that for everyone, because we like to have things in the lowest possible terms when we're writing math, right? So now I'm going to write f of x is equal to, and then negative x plus 5 minus x minus 3, negative x plus 5 plus x plus 3, x minus 5 plus x plus 3. And then I'm going to have these statements here again, right? If x is less than negative 3, if negative 3 less than or equal to x, less than or equal to 5, if x is greater than 5, right? And I'm going to clear this up just to make some room for myself. And then I can go back to writing f of x is equal to, and then combining all these terms, I'm going to get negative 2x plus 2 if x is less than negative 3. Then I'm going to get these two x's to cancel. So then I'm just going to get a constant, actually, 8, if x, oops, sorry, if negative 3 is less than or equal to x, is less than or equal to 5, and if x is greater than 5, I'm going to get 2x minus 2, and that's going to be my final answer for this guy over here. Right, is going to be that guy. Clearing this up just a little bit. There we go. And so that's going to be my final answer. So hopefully that helped you guys. Let me know in the comments and subscribe.